Scientists claim to have found a new element outside the periodic table in a rock from outer space. Be sure to stay tuned to the end for original footage of this asteroid and the answer to the question of what this new element is all about. And if you like it, I'll be galactically happy about a thumbs up and a comment, because that's how we get the algorithm to show this exciting topic to even more people. Thank you guys and welcome. Today it's all about elements. So I'm fully in my element. Oh no, if the video starts with such a joke. To understand whether a new element has been discovered, we first need to look at what elements are. Elements are the most basic building blocks of matter. Each element consists of atoms that have a certain number of protons in their nucleus. This number of protons is called the atomic number, and it is characteristic of each element. For example, hydrogen has atomic number 1, helium has atomic number 2, and so on. There are a total of 118 different elements listed in the current periodic table. But there is one more question. What is the periodic table? The periodic table was developed in the 19th century by Dmitri Mendeleev. For some, it probably brings back dark, traumatic memories of chemistry lessons. Mendeleev organized the elements known at the time in a table according to increasing atomic number and similar chemical properties. This led to elements with similar behavior being placed in the same columns or groups. This grouping in turn made it possible to predict the properties of elements that had not yet been discovered at the time. Ingenious. And today the periodic table ends at 118 elements, because this is the number of elements that have been discovered or synthesized so far. The atomic numbers of these elements range from 1 for hydrogen to 180 for organosine. So far, so good. That's all the elementary information. But why should it stop at 118? And that's where a cosmic object comes into play, the asteroid Polyhymnia. It is part of the asteroid belt between the planets Mars and Jupiter. As I always say, the asteroid belt is a kind of construction waste left over from the formation of the solar system. Billions of years ago, the inner planets were made up of dust and rocks, and the stuff that was left over is still flying around in the asteroid belt today. Mysterious chunks arranged in an orbit around the Sun. Polyhymnia is actually just one of many asteroids. A lump of rock like any other. If it weren't for one property, its density. As with people, everyone knows someone who is no different from the average, except that they are often particularly dense.
Are you being intentionally dense?
Huh?
The density of Polyhymnia was calculated to be 75.3 grams per cubic centimeter, which is more than 3 times denser than the densest known element in the periodic table, namely osmium, with a density of 22.59 grams per cubic centimeter. How can this be explained? The density of an object obviously depends on the materials it contains. In the case of Polyhymnia, it is quite unlikely that the known elements from the periodic table alone can explain its exceptionally high density. So the obvious explanation for the density is that it contains materials that we have not yet synthesized in the laboratory or found in nature. In other words, elements that are not yet part of the periodic table. A team of researchers from the University of Arizona has published a new paper on the subject. The mass density of this asteroid is thus far above the maximum density of known atomic matter. We therefore wanted to investigate whether these compact ultra-dense objects could consist of super-heavy elements beyond the periodic table. And now the genius of the periodic table comes in handy again. Since we know how dense Polyhymnia is, we can extrapolate where a suitable element should be located in the periodic table. The research team believes that there are hypothetical islands of stability in the periodic table where elements with higher atomic numbers could exist for longer. To explain the density of Polyhymnia, they used the Thomas FMY model of atomic structure to investigate the possible properties of elements beyond atomic number 118. For example, an element with atomic number 164 might be able to explain the extraordinary density of Polyhymnia, provided it was stable enough not to decay immediately. So that's right, to explain the density of Polyhymnia, the researchers make a direct leap from number 118 on the periodic table to number 164. This reminds me of the following statement by a famous physicist and philosopher.
Magie ist Physik durch Wollen, noch einmal, vergessen Sie es nicht.
But how do you extrapolate something like that? It's a bit tricky. The research team used the Thomas FMY model. This indicates how large the radius of the positively charged atomic nuclei of a metal is, i.e. the part of the atom that contains the atomic nucleus and the electrons that are still firmly bound to it. And how densely the atoms in a metal are packed depends primarily on the radius of the nuclei. The researcher involved, Jan Rafalski, describes it like this. We used the Thomas FMY model because, despite its relative imprecision, it allows a systematic exploration of atomic behavior as a function of proton number even beyond the known periodic table. And the calculation showed that element 164 should have an atomic body radius between 0.13 and 0.16 nanometers in size, and that this would fit perfectly with the density of polyhymnia. But this is actually a bit of physics by will, because it is extremely controversial among scientists whether such super-heavy elements exist beyond the periodic table. In specialist circles, this is also referred to as unobtainium, i.e. an unattainable element. And as the name suggests, it has so far been considered impossible to produce these elements in the laboratory. I would therefore find it super exciting to send a probe to Polyhymnia, which would then bring a piece of this asteroid to Earth. Similar to the OSIRIS-REx mission, in which NASA succeeded in safely transporting fragments of the asteroid Bennu back to Earth. What an absolute sensation it would be if a space probe could bring back material from space that blows up the periodic table. A cosmic Uber Eats delivery of fresh unobtainium. Which begs the question, what would element 164 taste like? I would be very interested in your opinion. Can the density of polyhymnia be explained by a new, super heavy element? And if so, please write your name suggestions for element 164 in the comments, because of course we need a fantastic name for such a special element. I'm really looking forward to your creative suggestions. In the YouTube periodic table, my channel will soon reach atomic number 25,000. I'm really only missing a very few subscribers until then, and I would be very happy if you would help me to reach this galactic goal and follow my channel now and recommend it to your space-loving friends and family members. Thank you very much, guys. Some elements on Earth probably first came here through asteroid impacts. And what researchers have now discovered Australia points to one of the most violent impacts of all time. Under Australia, they discovered a mysterious structure that is larger than anything we have found so far. It's amazing how we could have missed it until now. Take a look at the incredible footage of this gigantic structure under Australia in the video below. It's really very exciting. And if you want to support my work, treat yourself to the t-shirts from the videos and great plush planets in my Astro store. Every purchase helps me a lot to continue the channel. Otherwise, I'd say see you in the next video. Take care, guys.